Welcome to Lesson 6. In this lesson, we will have a look at functions, which are simply executable units of code within a contract. As in JavaScript, functions may take parameters as input. Note how you also have to denote the data type used for the parameter. So as in this example here, we have to declare the data type being used. So in this case, we have input 1 of data type uint and input 2 of data type address. Unlike in JavaScript and C, functions may also return arbitrary number of parameters as output. And one limitation of Solidity is that you cannot return dynamic arrays as of yet. This functionality is coming soon. Below is an example of a function with one return parameter. Note how return keyword is not necessary here, since we return variable m and declare it within the function. Variables can be omitted in returns. Then we have to explicitly declare the return statement, like we do so here. Below is an example of two output values. So instead of just returning one output value, we can also return several. So we do it like this. We declare several output values, and then whatever is the last declaration of these values is what will get returned. Below is another example of returning multiple values, but when omitting variable names to be returned. So here we only declare the data types which we will return, and then we have to use parentheses to return the values. Functions can be called using either positional or keyword arguments which are passed as a JSON object. In this function, we have two parameters which are of names, key, and value. In first example, we call this function by using JSON object where the keys are the names of these parameters. And in the second example, we just use the positional arguments as usual. Now let's have a look at function types which exist in Solidity. Since Solidity version 0.4.16, there are two function types to keep in mind: view and pure. View functions read from blockchain storage but do not write to it. View acts as a replacement for constant keyword, which was intended to be used by functions that do not modify the state. So here we read foo variable from the state and we return it, but note how we do not set any variable to the state. Pure functions do not read or write to storage. They simply interact with the input parameter that was passed to them. In the example below, as you can see, we simply invert the Boolean value we got passed and return that. This does not read from the state or write to it. Now let's have a look at this full example and explore how this works. Copy the code, which you can find in this GitHub repository at lesson 6. Go to Remix IDE, make a new file, call it whatever you want, paste the code, and then let's deploy it. Before we do so, we have to select JavaScript virtual machine and let's deploy it. So here we have four functions: write to storage, read from storage constant, read from storage view, and pure function. The first write to storage function simply writes the inverse value of foo to state. So as you can see, we don't declare the function type here, so it's neither constant nor view nor pure. In read from storage constant function, we return the variable foo, and it simply returns this variable, as we can see here. It's true. Now view function is the same as the constant function in this example, and if we call it, we will get true as well. Now as I said, since Solidity version 0.416, view is the replacement for constant function type. Pure function is the last example of function type. So in this case, it simply gets a parameter, bar, and returns the inverse value of it. As you can see, it neither writes nor reads from the state of this contract. And if we set a value here, for example, we set it to true, we will get false. Now let's try this write to storage function. It will set foo to its inverse value. So now it is set to true, and now it should be set to false. Let's retrieve the values from here, and they are both false. Alright, that's good. Now let's have a look at function modifiers. Function modifiers can be used to amend the semantics of functions in a declarative way. So let's explain this by using an example. So copy this code again, go to Remix IDE, make a new file, call it whatever you want, so untitled2 in my case, and let's deploy it. Now what function modifier is, in simpler words, is that it simply allows to amend some functionality to another function. So in this case, let's say we have a contract with a kill function which allows to kill the contract by calling self-destruct function. But before it does that, we need to make sure that only the person who created this contract can do this. So in this kill function, we declare a function modifier only owner, where we check that the message sender is the same person as the one who set up this contract in this constructor function. In this manner, we make sure that nobody except the owner can kill this contract. You can see how function modifiers can be useful for this and many other cases where we want to reuse some kind of functionality in many functions. So this is it for this lesson. In the next lesson, we will have a look at visibility types for functions and variables.